Hi, in my previous videos, I have shown you how a simulated flight controller can be connected to the ground station and how an actual flight controller can be connected to the ground station, and even how to relay packets from a drone which is not connected to the ground station back to the ground station, uh, just like in this one. So those three has been already explained, and in this video what I'm trying to explain is how to run a custom application. That's, you can call it a third-party application in the ground station along with the ground station application, and connect both of them to the real flight controller. It doesn't matter whether it is the real flight controller or a simulated flight controller. Now you know how to connect either of those back to the ground station. So how these two applications can be communicated with a flight controller, whether it is real or simulated. So here we have the drone. So drone in the sense the flight controller. Drone is nothing without the flight controller. So I'm having only the flight controller with me. I don't have the frame right now. So we have the flight controller. We have a Raspberry Pi where we want to write our other applications, and we have the telemetry radio antenna. And that telemetry radio antenna is connected to a telemetry radio antenna in a ground station using the RF link. And in my ground station, we have QGroundControl, the ground control application, and the custom application running. Now, my ground station is running on top of a Windows computer. Since it's a Windows computer, uh, I can't straight away run MAVLink or MAVProxy. Because of that, I'm going to use a separate setup. But if you have a Linux computer, that can be directly done. So now the problem is this. Here, the problem that I'm trying to address here is this. Even in my previous video, I have explained that when the QGroundControl application is running, so that will be directly bounded to this antenna through the USB connection, right? So this application directly binds to this telemetry radio antenna. Because of that, all the packets coming through this link will be routed to the QGroundControl application or the ground station application, and that cannot be accessed by other applications, right? So if you want to route those packets to other applications as well, you have to have the MAVProxy running in between these to route those packets. So MAVProxy should receive the packets and route it to the custom application or the QGroundControl application. Now for that, I have to have MAVProxy running in the computer. Since this is a Windows computer, I have to run a separate Linux environment in order to run MAVProxy. So I don't want to bother about it right now since I have Raspberry Pis with me. So what I'm going to do is I'm going to have a Raspberry Pi in between. So here the QGroundControl is connecting to, in fact, I think, yeah, QGroundControl is connecting to, port 14550, and the custom application is connecting to the port 14553. So for that, what I'm trying to do is to have a Raspberry Pi here, and in the Raspberry Pi, I'm running my MAVProxy, and that MAVProxy will route the packets to this QGroundControl application and the custom application. So these two can be connected directly through a wire, or it can be connected through the local network. So I'm connected to my router through the local. So I'm having a local network running. So this Raspberry Pi is connected to uh, the router. This ground station is also connected to the router. So through the local network connection, these two are having a connection. So I can route the packets, right? So here MAVProxy from the flight controller will be sending packets to the MAVProxy of this Raspberry Pi, and that will route the packets to the QGroundControl application and the custom application. So here I have my flight controller with me. So this is my flight controller and the GPS attached to the flight controller, and I have my Raspberry Pi and my telemetry radio antenna. These represents the drone itself. So I can just simply mount this on top of the drone, right? And then I have my Raspberry Pi in my ground station and my telemetry radio antenna. So that is this Raspberry Pi and this antenna, right? So using this computer, I'm connected to both those Raspberry Pis through a network connection because I want to show you what's happening there. And then I will just remove the local connection as well, the network connection as well, and show that without even the network connection, this is working. Otherwise, you might think that I'm using all these inside the local network. So for that, first I will go to these two Raspberry Pis. So this first Raspberry Pi, see, I have already lost the connection because I disconnected it from the local network. I have to get the connection back. So now I'm connecting to my drone itself, right? So this is my drone. Oh, the Raspberry Pi attached to my drone. So it is connected to the Raspberry Pi is connected to the flight controller, and it is already running. So if I move on to my ground station application, you can see it's not ready, but it's connected. Right now, if I disconnect this, you will see that it's gonna get disconnected, right? So I'm gonna stop my flight controller's connection. Right now, the flight controller's connection is stopped. Right now, if I go back to my ground station, you will see now the communication has lost. Right, so I will run the flight controller back again. So in my flight controller, I have this one corresponds to this master equal to /div/tty SEM1. This one represent to the connection between the Raspberry Pi and the flight controller, and this out equal to /dv/tty USB1. This one represent the connection between the Raspberry Pi and the telemetry radio antenna. Right, and I'm routing my packets. I want to route my packets to my ground station. So my ground station IP is 192.168.0.5, and the ground station application port is 14550. And so forget about this one right now. We don't need this one actually. Sorry. Then this 192.168.0.5 is again the ground station, and I'm sending the packets to 14553 as well. That is the other application running in the ground station, right? So if I run this, now you can see here the connection is again established, right? But that connection is established through my Raspberry Pi in the ground station, as I have shown in the slide. So that is connecting to this one. So I will log on to that Raspberry Pi. So that Raspberry Pi is this one, right? So now I'm going to disconnect that Raspberry Pi by MAVProxy. Right now the MAVProxy is stopped. So when I stop that MAVProxy, still the connection is there because this is connected through the local network, right? So now let me disconnect the local network connection of this Raspberry Pi, that is the flight, right? So if I disconnect this connection, now all the connection will be lost, right? So now I will keep this in my hand, and I'll go back to this Raspberry Pi's connection. So this is this Raspberry Pi. This is the ground station Raspberry Pi. Now I am going to run the MAVProxy back again. So in my MAVProxy, this master equal to /div/tty USB0. This one corresponds to the telemetry radio antenna. So that is this black connection, right? And so this other sorry, this is not the ground station one. This is the flight, right? So this one corresponds to the flight controller. This one corresponds to the antenna, right? So this is my local Raspberry Pi, right? Now I have already disconnected my network connection from my flight. So I don't have access to this Raspberry Pi, right? So I don't have access to this one. So I can't do anything. The connection has lost, right? So the connection is not there anymore. But the flight is running, right? So the flight controller is running. And this particular router, sorry, the MAVProxy is running in here. So this routes the packets to the ground station applications. So now if I run this one, so here what I'm trying to do is I'm running MAVProxy. I'm connected to my telemetry radio antenna, and then I'm routing the packets to this my ground station application or QGroundControl and my custom application, or we can call the third-party application at port 14553, right? 14550 and 14553. I'm routing the packets. So if I run this, now you can see this is getting connected back again, right? This is getting connected back again. So this local connection is there because this is the local network. I am connected to my router through this blue network cable. So this is the local connection is there. So I'm connected to the flight controller through this telemetry radio antenna, and I can see my vehicle 1 is connected. So this is not all, right? Now the connection is established to the ground station. I'm still not running my third-party application, or we can call the custom application, right? So in order to run the custom application, in my Windows machine, I'm using Anaconda Python environment. However, you can just run it in that Raspberry Pi or in your own Linux environment as well. So here in this environment, sorry, no, that is not this one. That is this one, I think. Yeah, this is my Conda environment. So I will disconnect what is running right now. This has been the one that I was executing. So I will run that application back again here, right? So this is in my particular folder, and I'm running my ground station application. So when I run my ground station application, so this is a very simple application to change the mode of the flight, right? So my vehicle ID is 1. I will set the vehicle ID to 1. And if I, from this guided mode, if I want to change this to stabilized flight mode, so if I say set to stabilize mode, so it goes to stabilize mode, right? You might have even heard a beep. That beep is coming from this flight controller, right? I'm sending through my ground station Raspberry Pi to my flight controller's Raspberry Pi to the flight controller. So if I want to get this back to guided mode, right, you can see now it has come to the guided mode back again. I'm sending it back to stabilized mode, right? So now you can see I can communicate to my flight controller through my ground station's third-party application. How did I do that? That is through this connection, right? So in my ground station, I have my QGroundControl, the original application, and my custom application. Those two are running in 2 different ports. And in order to route the packets to these 2 different ports, I'm using my Raspberry Pi's MAVProxy. That is, I'm running MAVProxy in this Raspberry Pi, and this one is connected to the. These two are connected through a local network connection, and the flight or the drone or the flight controller is connected to the ground station through this RF link through the telemetry radio antennas, right? So that's it, what I wanted to show. So the simple application I will write in the description. And regarding this Anaconda and not this one again, this Anaconda environment. So this is in fact the Anaconda prompt. So if you install Anaconda in your Windows machine, so this is the Anaconda prompt. So there you have to create a virtual environment. In that virtual environment, you can install MAVLink and MAVProxy. And once you install MAVLink and MAVProxy there, you can run your Python applications having the MAVLink protocol in it, right? Or else, if you are using the Raspberry Pi, you have already installed MAVLink and MAVProxy in the Raspberry Pi. You can simply run this application in your Raspberry Pi without having any other thing installed. Just activate your virtual environment and run the Python application, right? So I will give the code to the Python application, and rest is already explained in the other videos. So you can go back to the other videos and see those explanations. Right? Okay, thank you.